So, hello, my name is Nate Bade. I'm currently the program director for the Applied Mathematics Master's program at Northeastern, and I'm a teaching professor there in the mathematics department. And I'm in sort of the machine learning data science side of this application. And I want to talk to you today about feature construction, and as a sort of introductory lecture, why should we construct features by hand? The notebook that I'm going to be going through. So this is going to be sort of what would be more of like a lab style class as opposed to a lecture style class. But the notebook that I'm going to go through is linked to the bottom of this video. Okay, so let's get started. So the background material here would be that basically we'd done preliminary analysis with Python. We looked at some data sets. We'd done some multilinear regression. We looked at correlation. We looked at some of the data cleaning process as well. So for instance, you know, one of a previous lab might be something like looking at medical records, patient medical records, or patient medical record data sets, and showing that you can recover things like ethnicity from, you know, from just the medical information in the data set. So, and talking about the difficulties around that. So in this lecture, though, we're going to see that sometimes you can't just throw a linear classifier at things. So in this example, we're going to look at the Airbnb review data set for New York. And actually, I'm going to just look at a slightly truncated version. This is quite long. So this is about 10,000 records that I'm just hosting on the GitHub. And you can see we've got some string-like features like the name. We've got some numerical features, latitude and longitude, price, etc. And then we've got some categorical features, like the room type and the neighborhood. In this case, we just want to look at the numerical features, and we'll see. We also just want to look at a couple. So what we're going to try to do here is try to predict the price of the Airbnb based solely on the numerical features. So we go through as usual, so we only keep the numerical features. We see that there's some nans here. This is when the number of reviews is 0. Then the reviews per month is nan, so we'll just clean those up, fill them in with zeros. Check. Yep, great, no more nans. And then take a look at the correlation matrix. So the correlation matrix here, we're interested in price. We want to predict it from the numerical variables, and we see that we are really sunk. There's basically no correlation that we can see. So what do we do? Well, the first thing that we should do, of course, is we should actually, maybe a little bit unlike previous examples that we would have seen, we should actually think about whether these, the features make any sense. So minimum number of nights probably doesn't really correlate with price. Availability very well may not correlate with price, right? These might just be indicating that there's nothing to see here. Latitude and longitude, though, is different. So latitude and longitude is the spatial location, and that should tell us a huge amount of information about the price, right? You know, is it on the beach? Is it in Manhattan? Is it near Central Park? You know, where is it? Somewhere way off in the boonies? Like, you know, all this information should actually somehow be giving us a huge amount of information about what the price could be. So why can't we see it? Why can't we extract it here? And there's a couple of reasons. So, I mean, first, let's just look at scatter plot of the latitude versus the price. And we see kind of two big issues. So the first issue is just outliers, right? We've got 10,000 data points, and everything from $4,000 to $10,000 a night it's about 10 data points. So the first thing we should do, you know, if we're interested in these outliers, we can certainly keep them, but I want to cut them out. I want to get a more general trend here. But the second thing we're seeing is that there does seem to be some pattern. It's just not a linear one, right? What correlation is going to see is if we increase the latitude a little bit, we want to see the price go up. Or anti-correlation, if we increase the latitude a little bit, we want to see the price go down. We're not seeing that here. We're seeing something a little bit more complicated. So let's cut out everything above $1,000. And here we go. And we see this even becoming more true. There's something going on, but we're not able to capture it. And as a little exercise, I'd say you just go through and verify that, in fact, even if we combine these two things into a multilinear regression, we still don't get very good results, right? So our R squared is nothing. Our F statistic is wacky. So, okay. So what if we plot the latitude versus the longitude? Okay. And all of a sudden, we have a city in front of us, right? If we add onto this the price information, so basically we're just going to use scatterplot to do that. And so scatterplot allows us to color each of these points by the price. And actually I have this as log. I will take that out for the moment and show you what happens here. So we specify that C is going to be, the color is going to be given by price. I also drop alpha down to 0.1 just so we can kind of get a more general sense of what's going on. And you can see that we have these pockets of high priced regions. It's not everywhere. There's definitely some distributed out, but we seem to definitely have pockets of higher and lower priced regions. The reason for the log here, so if we want to scale this a little bit, put this on a log scale so that, you know, as we sort of go up by a factor of 10, we don't just absolutely dwarf the lower prices. We can do that, and we see again a very similar kind of result. We've got some very high priced areas, and we've got some lower priced areas. So we can see that. That's completely obvious to us, but how do we get the computer to be able to see it? So let's focus in on Manhattan really fast. And we see all these features, right? You know, here's Central Park. We see, you know, the waterfront, different neighborhoods. And we'd like to take our visual information and our knowledge of the city, so all of our prior knowledge, the things that we actually know about sociology and human movement and where people live, and try to construct features from that information that will allow us to actually do some statistics and some hypothesis testing. So you guys are going to come up with one, or students would come up with one. But as a quick, just like first example, I'm just going to toss out as a hypothesis. Maybe Airbnb price has to do with the distance from the subways. So how do we think about that? How do we process it? And how do we test it, right? Okay, so what I need to do is I need to be very, very explicit about two things. One, I need some new data. I need to get the subway station locations, which is luckily easy to do. We can get it from the New York City Open Data Project. And then I need to tell you exactly how I'm going to construct this distance measure. So the distance from an Airbnb to a subway, we could try to do walking time or something, but we can just do Euclidean distance. That's going to be the easiest. So what we want to do then is we want to go through all of the subway stations and find the one that is the closest to that Airbnb and only take that distance. So formally, let's say the jth property is located at someplace xj, which is going to be longitude j, latitude j. Then the new feature is going to be, if each of our stations is indexed, so by station, so I is at longitude I, latitude I, then we can write the metro distance, or the distance to the metro, as the minimum of the distances from xj to station I. Where here distance is the Euclidean distance function. So it's your standard Pythagorean distance. So we'll dig into how to do this in the next section, but we can look at the result. And okay, it's interesting. It's not great. And if we go ahead and plot the subway stations over New York, we can see that there's a lot of subway stations in New York that don't really seem to correlate at all to where the regions to the regions where of high price and low price. So something else is going on. What is it? And so at this point, what I would do traditionally is I'd just put people, especially in a large class, into breakout rooms and say, you know, why don't you come up with 3 possible features that you can construct out of latitude and longitude data that may give a better indication of price. And in that construction, you should identify any data sources you'd need and do your best to kind of come up with an equation or description of how you'd actually then compute them. You know, it doesn't have to be as formal as this description up here, but you know, some indication of how you'd actually go about computing this thing. Well, hopefully this has piqued your interest a little bit about how we can actually, you know, do some feature construction by hand, and as to why it's necessary, right? There are, of course, machine learning algorithms that will do this kind of thing that are getting better, but there is so much, there's so much knowledge that we have, especially about things like spatial data, that you can get an amazing amount of information out of, just, 2 columns of data. 2 columns of data can be transferred in this case into this incredibly rich feature space that includes, a huge amount of sociology and history and geopolitical considerations. So, yeah, thank you very much for your time, and have a fabulous day.